Hi, my name is Victoria Fusha. Me and my colleague Ryan Pedizinin work on the Seawater Desalination project. So the goal of this project is that as the world population is growing, we have more and more people in the world that needs fresh water to drink every day. And thankfully, 97% of the water that we have is seawater, salted water. And the goal of this project is to show that we can have fresh water from salted water, and it could be very useful, and it's a very prominent technology that would be used in the future. So in this project, we'll analyze a current technology and metrics, then we'll go through a green proposition, and then we will conclude. The metrics for the current desalination process is we use 50 million gallons of seawater per day. So this is our process flow diagram, and we have an input of 50 million gallon of water per day, and the pre-treatment, which will take off our dirt from the seawater that comes in. Then we have the desalination process, which acts by reverse osmosis. And reverse osmosis is the process by which it try to counteract the normal process of filtration, and it uses higher pressures to do that. Then it converts it into fresh water, and then it gets distributed into the community. In order to do this process, it uses very high energies, in 15,000 kilowatt hours per million gallon of fresh water is used, and with a E factor of 1.476, which shows that we have a very high E factor, which shows that our waste, we have a lot of waste. And since our yield is 41%, you can also think that where is the rest going? Well, the rest of it that is not converted into fresh water is basically converted into brine. And brine is water with a high concentration of salt. The safety issues with this process is that it operates at very high pressures, like I said, 1,000 psi. So here we have a pump that pumps, in order for the reverse osmosis to happen, we need to have a pump that operates at 1,000 psi. And the inherent safety that we need to consider when building that pump is we need to implement a relief valve in order for, if it goes higher than 1,000 psi, then it can relieve the excess pressure. Then the safety of the operators and the safety of the plant will be taken into account. Also, what we need to consider is that if there's a leak, we use 50 million gallons of seawater per day. That is a lot of water. So if there's a leak, that will be most of the plant will be submerged. And we also have to think about, we're not only producing fresh water for the humans, but we're also taking water from the sea, which is the environment in which the marine life does live in. So what will happen to them? Then we went on into doing a life cycle assessment. First, we did a life cycle assessment on coal. So for each kilowatt hours of energy used, we produce 840 carbon dioxide. Why did we use coal? We use coal because it's in the United States, that is the source that is mostly used to generate energy. And here we have other pollutants that are also released during that process. Then we also did a life cycle assessment on brine, because as I said, this is the main waste that we do get from our system. So we analyzed it, and we found different ways of recycling it, such as surface water discharge, evaporation ponds, land application, deep well injection, seawater discharge, dust control. or de-icing agent. In North Carolina, we don't get much snow, but in other places, this might be useful. And also, we also need to consider the fact that this brine would need to be transported in those places, so that will be even more carbon dioxide that will be released into the environment. So this is why we have a green proposal. So our green proposal would be to change the way this current process is done, and how we would do that. Well, we would look at the energy that is used. We will replace that. Instead of using coal, then we will use solar power, which is a renewable sources, and also produce less CO2 per kilowatt. Then we also would look at technologies to increase our yield and also reduce our waste. That would help us reduce our waste. Since most of the desalination plants that are currently in use or in hot and arid places such as Northern Africa and Middle East, then using solar power would not be an issue.
Alright, so for this new technology that we were talking about, we came across the work of a man named Kamalash Sarkar, and he is a chemical engineer professor who was working on desalination processes. And he has this process where he runs the salt water through the membranes and tubes while heating them up and cooling them back down. And this, he was able to improve the yield up to 80%. And with this improved yield, the E factor was now all the way down to 0.2565, which shows that now you're generating a lot more product compared to your waste. And for the life cycle assessments on the solar generated electricity compared to the coal, you can see that we were able to reduce our CO2 equivalents per kilowatt an hours by 800, which was very significant. And also for the other air balloons, solar power doesn't really generate any of them, so we didn't need to factor those in. And here we have a nice table comparing the current process to our redesign. You can see both of them start out with an input of 50 million gallons a day, and the output of the old one with that 41% yield would get you around 20.5 million gallons of fresh water. But with the new design, you get 40 million gallons of fresh water. And you can see that 41% efficient to 80%. The E factor on the current was 1.476 compared to the 0.2565, which is a big improvement. Mass intensity went from 2.476 to 1.2465. Also, mass productivity went up from 40.4% to 79.6%. And then here's the CO2 emissions, which went from 840 to 46. So all across the board, when looking at metrics, the new process is considered much greener. And then we go to the economic analysis. So the original process, we found that a plant of that size would probably cost around $658 million. And it would get a rate of return around 0.1. But so for our new plant, it costs a little more, $1 billion, but it had a better rate of return because you're producing more water. And that higher cost is due to using new technologies, using the solar power. And usually in most cases, if you're using greener technology, it's a little newer, so you're going to spend a little more money. But you can see in the long run, you'll be making more money. So not only is it greener, but you make more money as well in the long run. And so to conclude, the waste is significantly less when looking at our method of generating electricity. We have the improved yield, which leads to producing more water and producing a lot less brine, so you don't have to worry about dealing with as much brine. And even though the new plant is a little more costly, ends up paying higher dividends in the long haul. Thank you.